All right, next up we have Andy Thomas. Andy is an oceanographer in the School of Marine Sciences at the University of Maine. His major research interest is in the time and space patterns of ocean processes, especially on larger time and space scales, and the causes drivers of these patterns. Andy specializes in the use of large time series of satellite data for quantifying these patterns and has over 35 years experience in the analysis of multidisciplinary ocean satellite data. His work is funded by NASA, NSF, and NOAA. Gosh, I can't believe I just said NOAA. Sorry. Prior to coming to the University of Maine, Andy served as the executive director of an NGO in Nova Scotia, Canada, focused on applications of marine remote sensing data. And before that, he was research faculty in oceanography at Oregon State University. Andy has a master's and a PhD in oceanography from the University of British Columbia and over 80 peer-reviewed publications. He teaches courses at UMaine in oceanography, satellite oceanography, and computer programming data analysis. And so when I asked Andy for some fun facts, he said his most recent paper on ocean climate change on the New England shelf got really excellent press coverage, including articles carried by the Seattle Times, the Washington Post, San Francisco Chronicle, Detroit News, ABC News, an NPR interview, which is like on my bucket list. It's never going to happen. But Science Daily and the Portland Press Herald and Bangor Daily News, which makes me happy that our local papers covered it. But that's really amazing, actually, for an academic paper to have that kind of press. And then the other one, I thought this was great. Andy grew up in the Caribbean, very sure he was going to become a coral reef biologist, diving and working in warm water on beautiful reefs. As a penance for some unknown sin, he has spent his entire career working on very cold mid to high latitude oceans, and then wanted to make sure that I pointed out that he doesn't regret a minute of it. So here's Andy.
So if you want to make measurements of the ocean, because it's so dynamic and so big, and expensive to move around on and slow, one of the best ways we have of doing that is to bolt instruments to satellites and send them up into space. So my lab is specialized in using the data from these satellites and looking at very large time and space scales of variability in the ocean. Of the data that we get from the satellites, probably the best data we get, the longest time series, we have 35 years of surface temperature data. Surface temperature is a critical component to measure in the ocean. It's directly involved in our weather. It's directly involved in the physics of the ocean through density, so circulation, and many critters in the ocean also have a magic temperature range within which they want to live. So measuring temperature is very critical. So when we look at the ocean, this is a global view dug out of the literature. The global warming trend in our global average ocean is about 0.1 to 0.14 degrees C per decade, depending on whose data you're looking at, but it's all pretty close. So we're warming under a climate change scenario. So my interest then is what's going on in our backyard. If the global ocean is warming at around 0.1 degrees per decade, what's going on? So let me show you some data. This is our backyard, so you'll recognize the map. The oranges and the reds are positive trends in temperature. The blues are negative trends. It's all orange and red, okay? And not only that, the Gulf of Maine, the Gulf of, let me go back, there we go. The Gulf of Maine and the Scotian Shelf are warming very rapidly, around 0.5 to 0.6 degrees per decade. So we are about 5 times the global average. So an interesting point then is, okay, if the temperature's warming, does this occur all year? Is winter and spring and summer all getting warm at the same rate, or can we see differences? Is there a seasonal bias? So we can break that trend into different months. And so here is the same trend, but now this is just the trend in January's, the trend in February's, the trend in March. So what you can see is that in this winter, the trends are much weaker. But in the summer, once we get into July and August and September, things get bright red. So now we're talking about trends that are up around 1 degree per decade, so 10 times the global average. Okay, so there is a very strong seasonal bias in when these temperature changes are occurring. Summer wins. Winter's not doing much. So of interest then is, what does this do, this seasonal bias in temperature? We've got summer getting warmer, much faster than winter. What does that do to our seasonal cycle? Well, we can measure that with our satellite data. So here's a seasonal cycle in temperature at any one location. It's cold in the winter. These are months down here. There's temperature. This is summer. If we take a slice across there, we can pick out the day that a piece of ocean crosses a certain temperature threshold and the day that it drops behind. And we call that the start of summer and the end of summer. And we can look at what the 35-year trend is in the start of summer and the end of summer. And so here we have these trends, and now look, we've got all these purple colors. Summer is trending negatively, so summer is starting earlier and earlier over our 35-year time period. Here we have the end of summer. The end of summer is all red. It's getting later and later. So guess what that does to the length of summer? It's getting longer and longer and longer. And look at that. It's getting longer in the Gulf of Maine. We win. The Gulf of Maine is getting summer longer by about 2 days per year. 2 days per year. So realize that what that means is over my 35 years of data, summer is getting longer by on the order of about 2 months longer than it was in the 1980s. So my take-home message here for you is then our shelf is warming at about 5 times the global average. It's not balanced evenly over the year. It's mostly in the summer, not much in the winter. Summer is starting earlier, ending later, and lasting longer. And thankfully or not, 2 months longer than it was back in the 1980s. So despite the snow outside, my message to you is summer is coming, longer and warmer than ever. Thank you.
Would you be so kind to suspend disbelief for just a moment and assume that I will adopt a calorie-restricted diet starting tonight? I'm 49 years old. I live 6 miles west of here. At what point will my house be underwater?
Okay, so I am not measuring the height of the ocean here. And actually, we are not in a region. What's up?
I'm sorry, wait a minute. That's a minute.
Oh. Hi, Kate.
Come join us. Come in.
How far above sea level is your house? Okay, so I'm very worried for those folks that are down in southern Maine that have those little beachfront houses along the. That is not good. Okay, if you're up on a bluff, I think you're fine. I'm great in Bangor. Bangor's we're fine. Okay, although we may be growing palm trees and not so much maple syrup.
Over there.
So I see all these reports of it being tougher and tougher to harvest things like lobster in southern areas. Is that coming to Maine because of things like this? Will it be harder to catch lobster here in the next 10, 15, 20 years?
Absolutely. And so what's going on is, as our temperature is going up, certain species have a magic temperature range they want to live in. So we have already chased the lobsters out of the southern end of their extent. The fishermen down in Long Island, in New York, New Jersey, they are not making a good living off lobsters. And so it will happen. We are lucky in the Gulf of Maine in that we have a lot of deep water tidal mixing, so it will be slower here. But yes, it is coming. Not necessarily just the temperature impact, but the things that come with the temperature. New predators that lobsters aren't used to, and new viruses and bacteria that they are not adapted to.
My question kind of tags along with that. The Gulf of Maine is famous for being colder, right, than the stream that's further out. It's starting from much colder water, right?
That's right.
And so can you describe, you just mentioned new predators, so what does it mean when the Gulf of Maine, will it equalize with the Atlantic stream out there?
No, they're all getting warmer. So eventually, no, that water's going to stay warmer. We're always going to have that gradient between the warm water off the other side of George's Bank, which is the Gulf Stream, and our Gulf of Maine will almost always be colder than that. But the rate at which we're warming is so much larger. And as our temperature warms, even though to us swimming is still cold, there are species that are sneaking around Cape Cod that we've never seen before because they now find that the temperature is suitable to them.
Of all the ramifications, what is the one that you're the most concerned about?
Probably the one I am most concerned about is that associated with this, and it's not what I've looked at here, is the increasing acidity in the ocean to do with CO2 flux across the air-water interface. We are making the oceans more acidic. And so all sorts of critters that depend on the pH of the ocean to make their living are not going to be able to. I think that's probably the biggest worry in terms of an oceanographic perspective. I hear this guy, though. There are plenty of people that are going to lose their houses, okay, due to sea level rise. That is unfortunately not shared equally around the planet. Some places are warming and the sea level is rising much faster than others, as I've showed you with temperature.
Is there any way to like reverse the effects, or is the best thing we can do just kind of like level them off at this point?
To reverse, well, my atmospheric science colleagues tell me we're pretty much past the point of turning it off. However, if you take a very aggressive stance against CO2 emissions, there is no question that we could ameliorate the situation. But no, I don't think we're going back anymore. But we can certainly mitigate it to a large extent.
My question has to do with how would this affect the plankton? I watched a TED talk about plankton as being really crucial.
Yes, so that's a great question. So one of the things, so it depends what type of plankton you're talking about, but let me put words in your mouth and say, let's talk about phytoplankton, the plants. Okay, so the plants that do the photosynthesis. So the way this impacts them is we're making summer longer. Warmer water at the surface means it's more stable. It doesn't mix as easily. And so our summer period of stratified, warm, nutrient-poor water is longer. And so we are reducing the productivity of our oceans by the process I've showed you today. We're done.